In the world of AI, we have almost handed over the keys to the kingdom. We trust these AI agents to interact with our most sensitive systems, our private data, and we just sort of assume the tools they use are safe. That is the critical question we are digging into today. Because when the very tools you depend on are secretly working against you, the consequences can be absolutely catastrophic. This threat has a name: MCP tool poisoning attack. And it is deviously clever. It's a silent kind of insidious method where attackers poison the very tools your AI relies on. They basically turn them into sleeper agents that can steal your data, sabotage your operations, or even seize control of your entire system. So, how exactly does an attack like this even work? To really get it, we need to take a closer look at what these tools are in the first place. These tools, they exist within something called as Model Context Protocol, that is MCP. Just think of MCP as a framework that helps an AI understand and interact with its environment. And the tools, well, they are the AI's hands and eyes, allowing it to reach outside its own code and do things in the real world. So, what are we talking about here? This could be a tool for pulling the sales figures from a database, another one for automatically sending an email, or maybe one that connects to your company's CRM. Each one performs a specific, pretty powerful job. And here is the key: each one has to be trusted to do only that job. And this gets us right to the heart of an attack. Tool poisoning is all about exploiting that trust. A malicious actor can slip in a very few lines of bad code, subtly changing how the tool behaves or even create a convincing fake. The goal is always the same: turn a tool you trust into a weapon. All right, theory is one thing, but let's walk through a realistic example to see just how silently and effectively this kind of attack really works. Imagine a sales team using an AI assistant. It's hooked up with its handy little tool called CRM Accessor, which lets the AI pull up some customer info on demand. Seems totally normal, right? It's a standard everyday use case. Now, this is where it gets really slick. On the left, you have got the original harmless code. Simple enough. But look at the code on the right, the poison version. The attacker added just one single, almost invisible line of code. And that one line is all it takes to secretly siphon off a copy of that customer data to their own server, right before passing that correct data along like nothing happened. To the user and to the AI, everything looks perfectly fine. From the user's perspective, nothing has changed at all. They just ask an AI for customer details just like they do every other day. And this is the genius of the attack. The AI calls the tool delivers the data, the user gets what they asked for, but in the shadows, a copy of that sensitive data is being funneled directly to the attacker. That trusted tool has become a Trojan horse, and absolutely no one has a clue. Okay, so a single compromised tool is bad enough, but the real danger here is how quickly this poison can spread throughout the entire AI ecosystem. Let's break down how this poison spreads, because it's like a domino effect. First, the attacker publishes their malicious update to a public tool registry. Second, because it looks legit, the registry accepts it. And then the real problem starts. Systems and AI agents that are set up for automatic updates start pulling down this compromised version. And just like that, a single backdoor spreads silently across tons of different organizations. So, look, learning about this threat is definitely frightening. But the good news is there are concrete steps you can take to actually defend your AI ecosystem. This is the most important question. How do you stop your trusted tools from becoming those Trojan horses? Your defenses have to be built on the verification and monitoring of it. It really comes down to four pillars. First, only install tools from verified registries you absolutely trust. Second, you have to use cryptographic signing. This is like digital seal of authenticity. If an attacker changes even a bit of a code, that signature breaks, giving you an immediate red flag. Third, you have got to continuously monitor your tools. Watch for any weird behavior like unexpected network calls to strange places. And finally, maintain detailed audit logs. Those give you a clear trail to follow if or when something goes wrong. Okay, let's zoom out for a second and put this whole thread into a broader context because this isn't just some new trick. It's a whole new category of risk. What we are really looking at here is AI equivalent of software supply chain attack. You know how a vulnerability in a single open source library can end up compromising thousands of apps that depend on it, right? It's the same idea. A single poison AI tool can infect countless AI systems. It's subtle, it's scalable, and it is incredibly dangerous new way to attack. If you take just one thing from all this, let it be this one. Trust is not automatic. It has to be earned and it has to be constantly verified. In this age of AI agents, you simply can't afford to be complacent about the tools your models are using. And that leaves us with one final critical question to consider. The very tools that give your AI its incredible power and its connection to the real world, could they also be its most vulnerable point of failures? So you need to ask yourself, how are you making sure they stay a strength and don't become the greatest weaknesses? Thank you.